Okay, on this one, we're going to compare the graphs of logarithms and the graphs of exponential functions. So notice when this one, a to the c is equal to b, and that's how we go from the logarithmic form to the exponential form. You can make it this I heart logs, we say sometimes. So if you have log base a of b equals c, it's a to the c equals b. So here's the logarithmic form and here's the exponential form. And you should be able to go back and forth between them. I find this transition to be very easy, to go from the log to the exponent. The exponent to the log, I have to think about it. It slows me down for whatever reason. Okay, so then what they asked us to do on this paper is plug in different values of x. So notice, if I have... if f, and then it's 2 to the x. So if I plug in -2, -1, 0, 1, and 2, I get 1/4, 1/2, 1, 2, and then 4. Oh, and they had 3. Okay. 2 to the third is 8. So when I graph this, it's doing something like this. Okay, draw it better on your paper. Here are the points to plot. This right here, 0, 1, is what we call the pivot point. And if we know where this one is, then we can figure out everything else a little bit better. This is an exponential growth. Notice how it's getting larger. And then the pivot point is here. It's how do I make my exponent 0 is what we want to think about with that one. The asymptote is the equation y equals 0. It's a horizontal line. The end behavior... the end behavior as x goes to infinity, y is going to infinity. As x goes to negative infinity, y is going to approach 0. And the domain is all real. The range is negative infinity, I lied, 0 to a positive infinity. Okay, now what we can do is we can take x and then f of x, we have a new, let's call this guy g of x, where g of x is equal to log base 2 of x. And so they said, okay, well what happens, here's where I am on the chart. I don't want to write on that paper because I didn't make a copy for me, I made one for y'all, and I'm too lazy to go back to the copy machine. That's the truth of it. Okay, if I plug in -2 here, then what I have is -2 is equal to log base 2 of x, and I can go 2 to the -2 equals x, which this becomes 1/4 is equal to x. Okay, if I have a -1 here, then I'm now going to have something very similar, except it's 1/2. If I have this 0, 2 to the 0 is equal to 1. 2, yeah, what am I doing? Now I have 1 is equal to log base 2 of x, 2 to the 1, x would be equal to 2. If I have 2 is equal to log base 2 of x, 2 to the 2 is equal to x would be equal to 4. 2, 4, and notice this would also be 8. Look at this, these two graphs, we have just, these aren't graphs, these are charts. We have switched our x and our y's, and so this is now the inverse function. And so I have the point 1, 0, and I'm going to get, as my x values get smaller, I'm going to get more and more negative. So it's going to be doing this sort of thing, and then it's going to grow. It doesn't grow as fast because it doesn't get to 3 until 8. See how that works out? So the asymptote now, it's no longer y equals 0. From before, we've switched x and y, and it's that. Oh, here's the announcement. Okay, well, check the answer key. It's not so bad. Basically, everything switches.